molecules. And
introduce yourself.
So I'm Raji.
I'm Valerie.
Use the remote. It's on your right.
Wait, no, how do you turn this on?
It's already on. Just touch it.
Just touch it. Okay. So some background information on what we work with are the proteins. A protein is any class of nitrogenous organic compounds that consist of large molecules composed of one or more long chains of amino acids and are essential parts of a living organism. The protein that we use is called myoglobin. Sol gels are solutions containing colloidal and inorganic particles in the process of being changed in gel. And nanoparticles are just nanoscale particles. The purpose of the sol gels are used to trap nanoparticles for the myoglobin protein to prevent the proteins from aggregating, which is to come together because that's what proteins do. The applications for sol gel derived products are numerous. Sol gels are used for a lot of different things. Sol gels are light and also tough, and they're used in thin films or also can be used in coating. In our experiment, they're used as films.
The protocol for testing the myoglobin reaction is 12. Conditions to follow are for the solution studies, 5 milliliters of H2O2, 25 microliters of myoglobin, all in 10 milliliters phosphate of buffer with pH 7. A sol gel encapsulated myoglobin studies, it was 5 milliliters of H2O2, 10 milliliters of phosphate buffer, and the same pH 7. The myoglobin concentration that will allow for UV-vis measurements with the bit signal to noise. In this experiment, you can follow either two ways: the H2O concentration, or you can follow the myoglobin concentration at 409 nanoliters and 421 mLs.
I just want to add that those two are like the independent variables that we'd be studying and what can be done.
Okay, our expectation is that a gradual decrease in the H2O2 concentration and a gradual decrease, but much slower in the overall MV concentration as slowly as it gets degraded. And what happens, the reason for this, like our expectation, is that the MV acts as a catalyst to speed the reaction of H2O2. And the experiment should test that MV encapsulated in the gels can still act as a catalyst for the reaction with H2O2. The rate of this reaction as compared to the reaction in the solution, and how does the sol gel encapsulation affects the degree of MV degradation. The control UV is, as for anything measurement, should be just the net MV in the buffer, which helps verify the MV concentration, just H2O2 in the buffer, which helps verify the H2O2 initial concentration, and taking the spectrum immediately after adding the H2O2 to the met MV and mixing this, this is the time 0. After mixing, you should initially try to measure as many samples as you can in the first 5 minutes. Then every 2-3 minutes up to the first 20 minutes afterwards at about 25, 30, 35, 40, and so on minutes. Then when it's sit and towards the end of the day try to sample again. When you see that all the H2O2 is depleted, then determine how much MV is left. Do not discard the samples. You can measure them again as time passes on and test if there is any additional decrease in MV signal.
Okay, so this is how we made the sol gels. TMOS mixture is what makes the solution into gel. And what we do is that we use phosphate buffer, and then we add 10 millimolars of HCl into the TMOS mixture, and that's what makes the gel. And we add the phosphate buffer. That's basically what we tested, and that's the liquid that takes up the space. And then the protein that we use, myoglobin, is what's being put into the mixture.
The polysign protocol was preparation of TMOS solution. We mixed 2 TMOS and 1 millimeter of HCl with a 1:5 ratio, and some cases where to prepare the nanogels in an Eppendorf tube, add 70 microliters of citrate phosphate buffer. Once again, this takes up a lot of space. Adds 10 microliters of desired protein. We use myoglobin. 10 microliters of polylysine and 10 microliters of TMOS solution. They mix and you let it stand for 5 minutes, and you dilute the solution with pure DI water, which is just diluted water, and you just wash it 3 times by the centrifuge. At the final wash, we suspend in water or dry it for half a day in room temperature, and then we suspend it in water.
No, Pico Pure water is water that doesn't have any minerals in it or anything. It's basically it's really cleaned out so that you make sure you don't contaminate anything that we're using. A sonicator is basically, it's like you put your tube inside the machine, and then it shakes and makes this really loud noise, and you have to use earplugs for that because that could damage your ears. Okay, so this would be the time for questions, and we'd also like to thank Celestina DaCosta, who have been working with us, Rita, and of course Professor Simoni, and the Harlem Children's Society.
Questions? Irish? Did you guys really add macromolecules into the soul gels?
Well, what we've been studying is buffers at first, but Celestina DaCosta, who's our mentor and a master's student, she's been studying that, and she shows us what the results are, because we're not really ready for that yet.
What else do you see coming down the pike if you're not ready for it? You know what I mean? What other results are you looking forward to or anticipating?
Well, basically what the whole research is about is to see how we can capture these things and how we can study it without it reacting with other things. So what we're hoping to look for in our research is a consistency, and also the research what we're using, the nanogels, can be used to study medicine and also other things. So not only proteins and stuff. Yeah.
So did you guys all work on this together, or did some?
Yeah. Each of us, we had a chance to make our own soul gels with we also worked with another student, but he's not from this program. But yeah, we got to work together and alone. Does you guys want to add anything? Yeah.
Who was your mentor?
Excuse me?
Who was your mentor?
Our mentor it's Professor Simoni, but we also worked with people who work in his lab, like Rita and Celestina. Is that it? Yeah, okay.